Hi, everyone. I'm Robert Dickert, and this is Fast End-to-End Testing with GraphQL. So, quick intro. I'm a developer at OKGrow, where we build web and mobile apps. We do GraphQL training. And we also run Assert.js, the first all JavaScript testing conference. Testing is a really important part of our culture at OKGrow, and we look at it as more than just quality control. We, as programmers, translate the business domain to working code. Now, if you haven't encountered the term business domain before, let's look at an example. If our domain is interpersonal banking, we can make some statements about our business regarding accounts, deposits, and so on. And we can extract specific terminology that describes our domain. Let's say we have a business requirement which states that clients can view their updated balance when they transfer funds. Very simple. Using that, we can formulate our testing scenarios. So here we have a requirement that's written in Gherkin, the language of Cucumber, using the given when then formula. So we have given Tony is logged in and he has a balance of $150. When he transfers $100 to Rodrigo, then his balance is $50. Okay. So let's look at that. Let's look at the breakdown between the client and the server. So the client needs to call the mutation correctly and display the outcome. And then the server needs to perform the actual transfer. So your app's domain is spread across the client and the server with different functionality in each. So let's say that we write client and server tests and get them to pass. Looks good. So is that enough? How confident are you in your tests? What if both tests are OK, but there's a problem with how the test is handled, or how the client and the server hand off data between each other? So in this case, your individual tests are green, but your end-to-end scenario is broken. What we want is a test that makes sure that the process can traverse all the way from the client to the server. And this brings us to end-to-end tests. Now, what people usually mean here is a full simulation of the app, including full client and full server environments. So we automate the input, we let it traverse the app, we run some assertions against the results as displayed in the browser, and it works, right? It feels good conceptually. So why don't we do this all the time? Well, the reason isn't a mystery to anyone who's used a lot of Selenium or tools like that. These tests can be really slow, too slow for test-driven development. And they're also brittle and hard to set up. But what's the alternative? What if we could have end-to-end tests that were fast, easy to write, and that could be run independently on the client and server? Well, there is a way. After all, we're using GraphQL, and it's already improved our process by getting front and back-end devs to agree on data requirements. If you think about it, every GraphQL operation can be specified by four things: the operation, the arguments, the context, and the response. If we look at how we use these on the server, it's a very straightforward API test. So we need to set a value on the database, and then we take the operation variables and context and pass them to run them on our GraphQL resolver, and then we can assert the result that comes back. On the client, it's a little bit different, right? We'll probably need to set a field state on a form component, and then we trigger our mutation, and then we execute a mocked-out mutation that returns our expected GraphQL results, and then we check to make sure that we displayed it correctly. So all very, very straightforward, and it sounds like they're working together, right? But how do we make sure that these tests are really, truly linked? Well, I would assert that the tests can be considered part of the same end-to-end process if four things are true. So if the operation that the client and the server are using are the same, if the variables that are passed by the client are the same ones that are used by the server test, if they are using a common context, and if the expected result that we get back from the server is used as the mocked value for the client, thus closing the loop. This is a contract test. Contract tests are usually used to confirm that an outside API that you depend on hasn't changed, meaning that we can count on the mocked values in our tests. Here, we are adapting that concept to assert that our client and server tests are, in fact, part of the same request. But how do we do this? The answer is to have two worlds in which the test runs. This comes for free if you use Cucumber, but you can implement this in other testing frameworks too. So let's go line by line in our test. So the first line is, given Tony is logged in. OK, well, our client is probably sending a token or a cookie or something like that. So we actually don't need to do anything on the client. On the server, we simply need to set the context for the GraphQL request. So the second line is, and he has a balance of $150. Again, on the server, we probably just need to set a test database or some kind of value that we're going to work against. On the client, we might not need to set anything, kind of depends on the app. The third line, when he transfers $100 to Rodrigo, okay, this is where the action takes place. This is where we trigger the mutation. And this is where we are setting variables, making sure they're passed as arguments. This is where we trigger the mutation. And then finally, we get to the last step, that his balance is $50 on the client. We translate this to check the UI result. And on the server, we check the response. So if we do these, it ties our tests together. And we can run either client or server independently and remain confident in our end-to-end process. That means we can use fast and lean tests that don't slow down our feedback loop. So tests in this paradigm can be very fast, certainly sub-second. So there's a few caveats. So first of all, you'll probably still want to have some end-to-end tests. You can just use a lot less of them. There's also a risk of mistakes that break the contract without you realizing it. Context is probably the most likely place for a problem, and that's one reason why auth is still a great place for real end-to-end tests. Finally, the setup for these tests is more complex than plain old integration tests, although it's probably easier and faster than setting up end-to-end tests. And for your trouble, you get tests that are a whole lot faster. And GraphQL makes this process really easy because it's so well specified that you can use a common infrastructure for all of your operations. It's also a really nice extension of the GraphQL-first philosophy. So you can not only agree on the schema, but do the tests. And then the front-end person can work on the front end without having to stand up the back end and have really rapid tests. So what do you think? If you're wondering where you can get this, we've done a proof of concept, but we haven't published it yet. We have used this in production code, but I'd love to hear your reactions. So come find me if you'd like to talk about this. And thank you very much for your time.